Hello everyone, welcome to MEMONEET. I hope all of you are doing good. So I am Aprajita, I am your chemistry SME. Today we are going to discuss the solutions of full length test 9. So let us start with the chemistry portion. And our first question means question number 51. So here we can see identify the correct statement regarding the conformations of ethane. So we know that ethane C2H6 it exists in two main conformation. The first one here that is given here, you can see that the hydrogens are just behind each other. So this conformation is called the eclipsed conformation. Whereas the second one, the hydrogen atoms are away from each other. This one is the staggered conformation. So you know here we have to find the correct statement. Let's study first what is torsional strain. So you know that the potential energy of these molecules it will increase because of the repulsion between the electrons. Means if the atoms are close to each other, the repulsion will be more and the energy will increase. More energy means more torsional strain. So this energy is nothing but the torsional strain. So more the torsional strain of the molecule will be less stable. Now if we look at the eclipse conformation, since the hydrogen atoms are quite close to each other, so there will be more repulsion and there will be more torsional strain. More torsional strain means less stability. So eclipse conformation would be least stable, whereas in staggered conformation the hydrogen atoms are away from each other, so there would be less repulsions, there would be less strain and more stability. And because of more stability, this is the most stable form in which the ethane can exist. So ethane exists in the staggered conformation mainly. Now let's have a look at the options. So the first statement is 1 has least torsional strain. This is wrong because 1 has most torsional strain. 1 is more stable than 2. This is also wrong because 1 is less stable. Ethane molecule largely remains in the second form. So that is true because they remain in the staggered form. And 1 is staggered, 2 is eclipsed. This is wrong because we have just discussed the first one is eclipsed and the second one is staggered. So here the answer is option number 3. Here we can see that. Now let's move on to question number 52. Given that the solubility product, so solubility product KSP of AgCl is given 1.8 into 10 to the power minus 10 and the concentration of silver ions are given 4 into 10 to the power minus 3 molar. We need to find the concentration of chloride ion that must just be exceeded before AgCl will precipitate. So before AgCl will precipitate, we need to find the concentration of chloride ion. So we know that KSP is definitely equal to the concentration of silver ions and chloride ions here. Okay, because here silver chloride will ionize like this, silver ion and one chloride ion. Okay, so if we put the values here, the concentration of chloride ion is 1.8 into 10 to the power minus 10 upon 4 into 10 to the power minus 3. So it will come out to be 4.5 into 10 to the power minus 8 molar. So concentration of chlorine must exceed this value. So precipitation will occur because the ionic product will exceed. So if the concentration exceeds this much, if the concentration of chlorine exceeds this much, the ionic product will exceed the KSP. Okay, so in that case, the precipitation will happen. So yes, the answer is 4.5 into 10 to the power minus 8. Next question 53. What is the correct order of spin only magnetic moment? So here we have magnesium 2 plus ion, chromium 2 plus and vanadium 2 plus. So we all know that the formula for magnetic moment is square root of n into n plus 2, where n stands for the number of unpaired electrons. Number of unpaired electrons present in the species. Okay, so here if we see Mn2 positive, so manganese is 3d54s2. So Mn2 positive would be 3d5 and there would be 1, 2, 3, 4. So there would be 5 unpaired electrons. Now in chromium 2 plus there are 4 unpaired electrons because it's 3d4, and in vanadium 2 plus there will be 3 unpaired electrons. Okay, so now if we put the value of N here, we can find the value of magnetic moment for all of these. So clearly we can see more the value of N, more will be the value of magnetic moment. So manganese is having highest unpaired electrons. It will be having the highest magnetic moment, followed by chromium 2 plus, followed by vanadium 2 plus. So here the correct order is option number 3. Now the next one is, which of the following compound is formed in the borax bead test? So first of all, we know that borax bead test is used to identify or determine the specific metals that are found in the minerals that cannot be determined by the flame test or any other test. So what happens is, here we take borax, it is heated, it forms a bead, and then along with that, if we add the particular mineral, it will give you a colored bead. By looking at the color, we can get to know the metal. So basically, what happens in this case, we can write the equation. So here we are taking borax. On heating, it loses the water of crystallization and it forms a white opaque mass, Na2B4O7, and on fusion, it will form sodium metaborate plus boric anhydride. So this sodium metaborate and boric anhydride is formed. Now this boric anhydride further reacts with the whatever metal oxide we are taking. Let's say we are having chromium oxide. So it will react with chromium oxide to form chromium metaborate. Now this chromium metaborate will come out as a green colored bead, and we can get to know that yes, it is the chromium metal present in the given mineral. So basically what is happening, we are getting metaborate. So the answer is option number first, metaborate. Now question number 55, which of the given compounds is more susceptible to the electrophilic attack? So here we are having benzene, nitrobenzene, chlorobenzene and toluene. So we know that the groups which will increase the electron density on the benzene ring, they will increase the susceptibility to electrophilic attack. Okay. Now if I look at nitro group, it is an electron withdrawing group. So it will decrease the electron density and it will deactivate the ring towards the electrophilic reactions. So this is not going to be the answer. Now if I look at the chlorobenzene, so although in the case of chlorine, there is like plus R effect, but still like it donates electron by plus R effect, but still there is minus I effect. Minus I effect means again it's an electron withdrawing group. So overall it deactivates the ring towards electrophilic substitution. Now if I look at CH3, now CH3, yes, it's an electron donating group. It will donate the electrons by plus I effect, and because of that the ring will become susceptible to the electrophilic attack. And moreover, by the hyperconjugation also it will increase the electron density. So yes, the answer is going to be option number 4. So more than benzene, this toluene will be, or methyl benzene will be more susceptible to the electrophilic attack because of the presence of CH3 group. So the question number 56 is, the decomposition of substance follows first order kinetics if its concentration reduced to 1/8 of its initial value in 24 minutes, the rate constant would be. Now if I look at the rate constant of the first order decomposition, first order reaction, so it would be 2.303 upon T log A naught, means the initial concentration, upon A T, means concentration at time T. Now here it is given that at time T means 24 minutes, the concentration becomes 1/8. So if the initial concentration is 1 and the concentration at 24 minutes is 1/8, we can put the values. So from here 8 will go into the numerator and the value will come out to be 2.303 upon 24 log 8 upon 1 per minute. So yes, the answer is going to be option number 3. Now question number 57. Let's move on to that. In the Kjeldahl's method of nitrogen estimation, nitrogen is converted to nitrogen gas, nitric acid, ammonium sulfate, or nitrogen dioxide. Now when we do the nitrogen estimation, what happens in this case is nitrogen compound, whatever we are having, the nitrogenous compound, it is treated with sulfuric acid in the presence of copper sulfate to form ammonium sulfate. So ammonium sulfate is formed in this case, and which is then further decomposed with the alkali, so it forms the ammonia gas, and by the estimation of ammonia gas we can find the amount of nitrogen present in the compound. So yes, the answer is going to be option number 3, ammonium sulfate is formed. Now question number 58, molality of an aqueous solution of glucose whose molar mass is given is 1 molar. 590 grams of this solution is cooled and temperature is kept at minus 3 degrees. So when the solution is cooled, the temperature is kept at minus 3. We need to find out the amount of ice separated at this temperature. So first of all, we have been given the molality, which is 1 molar. So it means, molality means number of moles of solute present per kg of solvent. So it means 1 mole of solute, which is glucose, is present in 1 kg of the solvent. So that's what is written, and we know 1 mole of glucose would be 180 grams. So it means 180 grams glucose is present in 1000 grams of the solvent. So if we need to find out the mass of solution, so it will be 1180. So it means 1180 grams of solution will have 180 grams of solute. So according to the question, 590 gram solution will have 90 grams glucose, in which we have 90 grams glucose, 500 grams solvent. Now we will apply the depression and freezing point like the equation. So delta TF is I into the freezing point constant into molality. I will be 1 here because glucose is non-electrolyte, so the value of Van't Hoff factor would be 1 in this case. Now we put the value of delta TF, which is given 3. Because the temperature is kept at minus 3 degrees, means the temperature difference is 3 degrees. So delta TF is 3. Now the value of KF is given 2 Kelvin kg per mole. So that's what we are writing. Now molality. So here now we will be finding out the amount of solvent in this case. So number of moles, because since now we have 90 grams of glucose, 90 upon 180 divided by the mass of solvent that we are taking as X. So from here we can find the value of X. It's coming out to be 1 by 3 kilograms, means 333.33 grams. So it means earlier it was 500 grams solvent, but when the temperature was lowered to minus 3 degree, this much is left. So how much ice is formed? We will be subtracting it. It means around 166 gram ice is separated out because the amount of solvent has decreased. So the answer is option 2. Now next question. Question number 59. Which of the following statement is correct? So the statements are regarding the electron gain enthalpy. So first of all, we know, students, that the electron gain enthalpy is the energy released when a neutral isolated gaseous atom accepts the electron to form a negatively charged ion, that is the anion. Okay. So we know that the energy released is negative, of course. So noble gases have large positive electron gain enthalpy. This statement is true because noble gases are already stable. They have complete octet or duplet, so they don't require electron. If we need to add electron to it, the energy has to be supplied, and that to a large amount. So it means there has to be large positive electron gain enthalpy. This is true. Electron gain enthalpy become more and more negative with increase in the atomic number. So yes, when we are moving left to right in the period, what happens is electron gain enthalpy becomes more negative. Because the atomic size decreases and the effective nuclear charge increases, it increases the attraction of the nucleus for the incoming electrons. It means the electrons will be readily accepted and more energy would be released. So like we know that halogens have the most negative electron gain enthalpy. So this is also true. Effective nuclear charge increases from left to right. Yes, this is also true because electrons are added to the same shell. So the effective nuclear charge increases and atomic size decreases. The process of adding electrons to the atom is always endothermic. So this is wrong because energy is released when an electron is added to it. So that is exothermic. But suppose we are adding a second electron to our already negative ion. Let's say O negative is formed. Now we need to make O2 negative. So when second electron is being added, it will experience repulsion from the first one. So that is why we need to supply the energy. In that case, it would be endothermic, but in the first case, it would be exothermic. So it's not always endothermic. This is the incorrect statement and our right answer. Next is question number 60. When an electric current is passed through an aqueous solution of sodium chloride, what happens? So we know that during the electrolysis of sodium chloride, okay, in the presence of water, of course, we are having aqueous solution of sodium chloride. So what happens is hydrogen ions, they move towards the cathode and they are discharged at the cathode. Okay, and like there is a competition between sodium and hydrogen ions, but because hydrogen ions fall lower in electrochemical series, they will be discharged at the cathode, means hydrogen gas is evolved at cathode. Whereas in this case, the chloride ions, they move towards the anode and chlorine gas is liberated at the anode. So first two statements are wrong. Now if the hydrogen ions, they are being discharged at the cathode, means the concentration of hydrogen ion is decreasing. If the concentration of hydrogen ion is decreasing, the pH of the solution will increase. Because we know that pH is inversely proportional to concentration of hydrogen ions. So it means the answer is option number 4, that is the pH will progressively increase. Now question number 61. So here the answer is going to be 1. Please make a change of it. Means 13. Now here we need to see in the following sequence of reactions how many atoms in product Z are sp2 hybridized. First we need to find what is the product Z. So X is an alkyne with lowest molecular mass. So you know the alkyne with lowest molecular mass would be ethyne. CH, triple bond CH. So when it is passed through red hot iron tube, what happens is cyclic polymerization takes place and it gets converted to benzene. Now benzene undergoes Friedel-Crafts acylation reaction in the presence of 6H5COCl, in the presence of AlCl3. So Friedel-Crafts acylation will happen and we will get this product which is called benzophenone. Now you know that there are two benzene rings in this case. So each carbon is sp2 hybridized. So we have 6 here, 6 here, 6 plus 6, 12, plus this carbonyl carbon is also sp2 hybridized. So 6 plus 6 plus 1, it means 13 would be the answer. It's option A. Now question number 62. Which of the following ions has larger size although they have same number of electrons? So we know that F minus, Na plus, magnesium 2 plus, all of them are having 10 electrons. They are isoelectronic species. So in isoelectronic species, we know that the size of the anions is the greatest, then the neutral atom, and then the cation. Because in the anions, when more electrons are added, like here we are having O2 minus, so if more electrons are added, there would be a repulsion between the incoming electrons and the electrons present. So there would be decrease in effective nuclear charge and the size would increase. And out of F minus and O2 minus has 2 electrons, 2 incoming electrons, so it will be having the largest size. So the answer is option number 4. Okay, now question number 63. For the following cell with hydrogen electrodes, the pressure is given. These reactions are happening in this case. So we can write. So you know that at anode, what happens is H2 will lose electrons. So we can write oxidation will happen, and at cathode reduction will happen. 2H plus 2 electrons will give hydrogen gas. Okay, so this is the reaction that is happening. P1 is for here you can write at the anode, and P2 is the pressure at the cathode. So E cell, here we can write, here let's look. So here E cell is E naught cell minus RT upon NF log of product upon reactant. Like this is how we write it. So for E naught cell, since this is hydrogen is taken as the standard. So E naught cell for this would be 0. So it would be minus RT upon NF log of product upon reactant. That is log K. So since here the concentration of hydrogen would be taken as 1, we can write it in the form of pressure. So it would be minus RT upon, since the value of electron, the N is 2 here in this case. So it's 2F. Product mein we will be writing P2 and reactant side it's P1. So now it's negative. So to make it positive, we can write RT upon NF log P1 upon P2. So that is going to be our answer. Option number 4. RT upon 2F log P1 upon P2. Now question number 64. What is the major product of the following reaction? So here the reaction is given. So first of all, we can see in this reaction, benzene is reacting with chloropropane in the presence of anhydrous AlCl3. So first of all, this reaction is called Friedel-Crafts alkylation reaction of benzene ring. So first of all, the first step is the formation of R plus, means the electrophile generation. So in this case, the electrophile here, it is formed with the help of AlCl3. So we will get an electrophile which is CH3, CH2, CH2 positive. But since it is having 3 carbon atoms in this case, this rearrangement will happen to form a more stable carbocation which is CH3, CH plus, CH3. So a more stable carbocation is formed, and then it will get attached to the benzene. So the product form will be isopropyl benzene, CH, CH3, CH3, which we call as cumene also. So this is how this reaction will happen, and the answer is option number 2. Now question number 65. Consider the following set of statements. Thallium forms NaOH type hydroxide. So yes, thallium shows 2 oxidation state, +1 and +3, but +1 oxidation state is more stable because of the inert pair effect. So yes, it forms NaOH type hydroxide like this. Now tin, like Sn2 plus is a reducing agent, Sn4 plus is a reducing agent. So what happens in this case, that Sn2 plus is less stable than Sn4 plus. So it can lose 2 electrons to convert to Sn4, means it can get oxidized and it can act as a reducing agent. So Sn2 plus can act as a reducing agent, this is also true, but Sn4 plus cannot act as a reducing agent, this is false. So it's true, true and false. So yes, the answer is option number 3.
Next is question number 66.
which says what will be the concentration of solution in mole per liter if 18 grams of glucose is present in 100 ml of its solution. So here students, we can see, we know that molarity means the number of moles of solute, present in 1 liter of the solution, means we will say the volume of solution in liters. So this is the formula for molarity. Now here 18 grams of glucose is present in 100 ml of the solution. So glucose is C6H12O6 and its molecular weight is 180 grams. So number of moles of glucose will be 18 upon 180 and the volume is 100 divided by 1000 because we have to take the volume in liters. 100 ml was there, so it will come out to be 18 upon 180 into 1000 upon 100. So it's coming out to be 1 mole per liter. That is the concentration. So the answer is option first. Question number 67. Which of the following complex ions is diamagnetic in nature? So we know diamagnetic will be whenever there is all the paired electrons are present. Okay. So if I talk about COF6 minus, so here cobalt is present in 3 plus state. Okay, so cobalt 3 plus means 3D6 conformation will be there. So 3D6 may 1, 2, 3, 4, 5 and 6. Since fluorine is a weak field ligand, there won't be any pairing, then it will be sp3d2 hybridization will happen. Like we can draw it like this. So sp3d2 hybridization will happen and 6 ligands will be attached here. 1, 2, 3, 4, 5, 6. So here there are unpaired electrons present, so that is why it is paramagnetic. Now similarly we can do it for the other atoms, other molecules. So in nickel, again it is present in +2 state, Ni2 positive, and chloride is a weak field ligand. So it's 3D8, again there won't be any pairing, 1, 2, 3, 4. There would be like 2 unpaired electrons present in this case and the hybridization would be sp3. So again it is paramagnetic. In NiCN4, yes, Cn minus is a strong field ligand. So as you can see here, dsp2 hybridization will happen because the D8 configuration all will be getting paired up because of the cyanide group. So yes, here all the electrons are paired, so it's a diamagnetic molecule. Again in copper, CuCl2, again in this case there would be chloride, which is a weak field ligand. So again it's a paramagnetic molecule, there will be unpaired electrons present. So yes, the diamagnetic is option number 3. Now question number 68. Which of the following is correct about the product of this reaction? So here you know that alcoholic KOH, it will result in the dehydrohalogenation of alkyl halide. Now how does this dehydrohalogenation takes place? Bromine will be removed here and hydrogen can be removed from this carbon or this carbon. But according to the Zaitsev rule, the more substituted alkene is formed. So these options cancel. Now in the second option, this alkene is not substituted. So this one here, the double bond is between the 2 carbons. So it is more substituted. So the fourth one is the right answer. It is formed. So yes, the answer is option number 4. Because of the Zaitsev rule. Now 69 question number, compounds. So here we have been given 2 compounds. They represent linkage isomerism, ionization or coordination isomerism. So we know that if the compounds have same molecular formula but different structural formula, then they are called isomers. So in this case, the formula itself is not same because here it's chloride and here we have bromide. So there will be no isomerism in these 2 compounds. Now question number 70. maximum number of electrons in a subshell with L equal to 3 and N equal to 4 is. So we need to find the maximum number of electrons in this case. So now you know for N equal to 4 and L3. L3 stands for the F subshell. So it is 4F subshell, and you know that in F subshell there are 7 orbitals and each of them can accommodate 2 electrons. So 7 into 2, the maximum electrons that can be accommodated in 4F is 40. So yes, the answer is option A. Now question number 71, the most unlikely representation of resonance structure of para-nitrophenoxide ion is. So there are 4 structures given to us. We need to find out which one will be rock. So here we can see that in this case nitrogen is having a positive charge and forming 4 bonds. This is fine. Oxygen is forming a double bond. But in the second structure, just have a look. Nitrogen is forming 5 bonds. Okay, so it is forming 5 bonds, means 10 electrons are there. So this is not correct because nitrogen cannot have 10 electrons in this case. So, and moreover it is having a positive charge. So this one is rock. So this structure won't be stable and the answer would be option 2. Other structures are stable. Question number 72, students. The colorless species is, so you know that the compounds which are having 0 unpaired electrons, there won't be any DD transitions, no DD transitions if there is no unpaired electron. So the compound would be colorless. Now if we look at these compounds in VCl3, vanadium is in 3+ state, which is 3D2. 3D2 means 2 unpaired electrons would be there. So it would be colorless. It won't be colorless. Okay, it would be having some color. Now in the next compound, there is 3D, okay. So VOSO4 is given. Yeah, in VOSO4, so it's VO2 plus, no? So here there is 1 unpaired electron again. So because vanadium 4 plus is there, 3D1. 1 unpaired electron, again it would be a colored compound. Next here Na3VO4. So VO4 3 minus here. Vanadium is in 5 state. Now here there would be no unpaired electron because it's 3D0. So if it's 3D0, it would be colorless. In the fourth compound, vanadium 2 plus is there. So it, again 3 electrons, 3 unpaired electrons. So that means that it again would be colored. So third compound would be the colorless one, Na3VO4. Now next question, 73. Correct set of 4 quantum numbers for valence electron of rubidium. So atomic number is given. We can clearly write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6 and 5p1. So there is 1 valence electron, sorry 5s1, not p, 5s1. So the value of n is equal to 5, the value of L will be 0, M is also 0, magnetic quantum number, and the spin quantum number will be plus half since there is 1 electron. So yes, the answer is option number A, 5, 0, 0 and plus half. So that is the correct set of quantum number for the valence electron. Question number 74. Mole fraction of the solute in 1 molar aqueous solution. So we are having 1 molar aqueous solution. You know that mole fraction is number of moles of the solute divided by the total number of moles. Total number of moles means solute plus solvent. Now here we are having 1 molar solution. So it means 1 mole of the solute is present in 1 kg of water. Means 1 kg of, so since it's an aqueous solution, 1 kg of the solvent. So we can find out, now the moles of solute is given, the amount of solvent is 1000 grams. We can find out the number of moles of water, which is 1000 upon 18. So it's coming out to be 55.5 moles. Now we have got the number of moles. So number of moles of solute is 1 upon total number of moles will be 1 plus 55.5. So when we will be solving it, it will be 0.018. So the answer is option number 2. Next up, question number 75. The copper wire test for halogens is commonly known as. So you know the copper wire test is known as Beilstein's test, which is done for the halogen. So here copper wire is first cleaned and then it is put into the flame, and then along with the compound, whatever compound we are having, we will put it on the copper wire and we will see it in the flame. If we are getting greenish flame, so that indicates the presence of copper halide. Copper halide. So that confirms the presence of halogen. So it's known as the Beilstein's test. So that's the answer. Question number 76. Consider the above reaction and identifying the missing reagent. So here the reaction is CH3, CH2, COO, Na, NaOH plus whatever is the question mark, heat, CH3, CH3 plus Na2, CO3. So here you can see that there is a loss of CO2. Okay, so this reaction is known as decarboxylation reaction. So decarboxylation reaction takes place in the presence of soda lime. Now the soda lime is a mixture of sodium hydroxide and quicklime, which is calcium oxide. So calcium oxide or plus sodium hydroxide, it forms soda lime, which causes the decarboxylation of sodium salts of carboxylic acid. So here the decarboxylation would be happening and we will be getting ethane and sodium carbonate. So yes, the missing reagent is calcium oxide in this case. Next question, consider the following statements. All the elements of group 15 are polyatomic. So you know that group 15 element starts from nitrogen, then phosphorus, then arsenic. So nitrogen exists as a diatomic molecule. Others can exist as polyatomic. So this is not correct actually. Dinitrogen is a diatomic gas while others are solid. This is true. Metallic character. So you know when you are moving down the group, the metallic character increase, because the tendency to lose electrons increases as the atomic size increases and the nuclear charge decreases. So this is also wrong. So according to this question, only should be correct in this case. So you can see the answer here, it should be only 2. Because nitrogen is not polyatomic, it exists as a diatomic gas. Polyatomic means more than 2 atoms, like 3 or more than 3. Question number 78. 4d, 5p, 5f and 6p orbitals are arranged in order of decreasing energy. The correct option is. So if we need to find out the order of energy, we must look at the value of n plus L. Lower the value of n plus L, lower would be the energy. So we know that for 4d, the value of n is 4 and value of L is 2. So 4 plus 2 is 6. For 5p, similarly, it's 5 plus 1, which is 6. For 5f, it's 5 plus 3, which is 8. And for 6p, it's 6 plus 1, which is 7. Now we can say two values are same. So if the n plus L value comes out to be same, the one having the lower value of n will be having lower energy. Means 4d will be having the lowest energy, followed by 5p. Then we have 6p and then 5f. So we have to write it in decreasing order. So it's 5f, 6p, 5p and 4d. So the answer is option A. Okay. Next is two liquids X and Y. They are forming an ideal solution. At 300 Kelvin, vapor pressure of solution containing 1 mole of X and 3 moles of Y is 550 mm of Hg. Okay, then at the same temperature, if 1 mole of Y is further added, so 1 mole of Y is being added to the solution, the vapor pressure increases by 10 mm, means now it will become 560 mm of mercury. Now we have to find the vapor pressure of X and Y in pure state. So we will apply the law of partial pressure. So total pressure is x means the mole fraction of x into the pressure of x in pure state. Similarly, the mole fraction of y and the pressure of y in pure state. So that would be the case. Now mole fraction, we all know, number of moles of solute divided by total number of moles. So initially we have 1 mole of x and 3 moles of y. So mole fraction of x is 1 upon 1 plus 3, and for y it's 3 upon 1 plus 3. Okay, so we will put the values here. It's 3 upon 1 plus 3. Now similarly, 1 mole of y is being added. So now the mole fraction of x is 1 upon 1 plus 4, and for y it's 4 upon 1 plus 4 multiplied by their respective partial pressures. So that is equal to 560. Now we will be solving these two equations, and after solving these two equations, P naught x is 400 and P naught y means the vapor pressure of y in pure state is coming out to be 600. So it's option number 2, 400 and 600 respectively. Next is question number 80. Reaction of a carbonyl compound with one of the reagents involves nucleophilic addition followed by elimination of water. So what would be the answer in this case? So first of all, with Grignard reagent, yes, nucleophilic addition happens, but there is no elimination of water. So no elimination of water, it means this is not the right option. Hydrazine in the presence of feebly acidic solution. So yes, when hydrazine is being added to the carbonyl compound, yes, we are having this nucleophilic addition. Okay, like the lone pair will attract towards the carbon in carbon, and we will get an addition product. And after the elimination of water, we will get hydrazone. So yes, there is elimination of water happening in this case. Similarly, in hydrocyanic acid and sodium hydrogen sulfate, there is no elimination of water. So yes, we can say the answer is option number 2. Next, 81, water is less volatile than H2S. Now both of them are the hydrides of group 16. Now water is less volatile because you know that in water molecule there is hydrogen bonding. Hydrogen bonding between the electronegative oxygen and hydrogen. But sulfur atom, sulfur, it is actually less electronegative than oxygen, and it does not form hydrogen bonding in H2S. Because of hydrogen bonding, the water is less volatile than the hydrogen sulfide. So yes, the answer is option 3. Sulfur is less electronegative than oxygen, because of which it does not form hydrogen bond. Question number 82. Which type of amide typically exhibit the highest melting point? Now let's see the options. Tertiary, secondary, primary or amides. Now primary amides, they are having this functional group CONH2. Now they will have higher melting point than secondary or tertiary amide. The reason being they form strong hydrogen bonds. Now there is the presence of both NH2 is there. So hydrogen is there for the bonding, and from CO there is oxygen. So because of that they form strong hydrogen bonds, and the primary amides will be having the highest melting point. So the answer is option number 3. Natural sugar and amino acids are respectively DNL. So we know that mostly the natural sugar are dextrorotatory, means like D-glucose, D-fructose and all of like that. So they have D configuration, and the amino acids, they actually have L, levorotatory. So L amino acids are there. D amino acids are not found in the nature, like they are very rare. So L amino acids are there, they are levorotatory. So we can find out whether the molecule is D or L by looking at the Fischer projections also. D means when the OH is present on the right hand side, and L means when it is on the left hand side. And in amino acids, if NH2 is present on right hand side, that is D, and if it is on the left hand side, it's L. So that is why the answer is option A. Natural sugar exists as D, dextro, and amino acids exist as L configuration, which is levo. Question number 84. Element that cannot form MF63 negative ion. Now here we can see that boron, aluminium, gallium, indium. Boron is actually the smallest molecule out of here. And moreover, it is having no vacant d orbitals. Aluminium has, gallium, indium, all of them have. So there are no d orbitals present in the valence shell, and it cannot extend its configuration, right? So it cannot form MF63 negative like other atoms. So because of small size and no d orbitals, the answer is option 3. Next is determine the work done when 2 mole of an ideal gas compressed reversibly and isothermally from 10 liter to 1 liter. So for reversible and isothermal compression, the work done will be minus 2.303 nRT log of V final, means the final volume, upon the initial volume. So minus 2.303. Now N is the number of moles, which is 2. Now the options are given in kilocalories. So here we will see the value of R we will be taking in calories, which is around 2. Okay. Now 2 calorie per Kelvin per mole, and then log of V final. So it is like from like 1 liter and initial was 10. So we will be solving these values. Of course, temperature is 300. So we will be solving it, and it will be coming out 2.76 kilocalories. So that is the answer, option number 4. Now let's move to the section B. Question number 86. Arrange the following molecules in correct order of their acidic strength. Now we all know that whenever there is an electron withdrawing group present, it will withdraw the electrons and it will enhance the acidity of the phenol. Okay, means it will activate the ring here in this case. Now in these options, NO2 is the one which is the electron withdrawing group. So it will be like enhancing the acidity of phenol. So fourth will come at the first position, means it will be the most acidic. Now if I look at phenol, it would be there, because OCH3 and CH3 would be electron donating groups. Okay, so OCH3 has plus R effect also, because of the lone pair present on the oxygen, it shows plus R effect. So it will be having more electron donating nature than the methyl group. So here what will happen, like this one will come first, that is the third one, and OCH3 will come at the last, means it will be least acidic because of the higher electron donating nature. So 4 1 2 3 would be the 4 1 3 2 would be the answer, which is option number 2. So CH3 actually has only plus I effect, no, but OCH3 has plus R effect also, because of which it deactivates the ring more than CH3. Now question number 87. If the enthalpy of fusion of a compound is 49 kilojoule per mole, so enthalpy of fusion is given 49 kilojoule, that is delta H, so we can write it as 49,000 joule per mole, and the temperature is 77 degrees Celsius, so we can convert it to Kelvin by adding 273 to it, so it will be 350 Kelvin. Now we have to find the molar entropy change. So you know that delta G is equal to delta H minus T delta S. Now since fusion is happening, that is melting is happening, so the system is in equilibrium, so the delta G value would be 0 at this case. So because it is at the melting point, means it is at the equilibrium stage. So delta H minus T delta S would be 0. So delta H is equal to T delta S, and from here we can find the value of delta S. Delta H upon T means 49,000 upon 350. So it's coming out to be 140 joule per mole per Kelvin. Now question number 88. Why do the deviation occurs from the idealized shape of H2O and NH3 molecules? So they are not having here you can see that the deviations from idealized shape, they actually happen because of the presence of lone pair. Because whenever lone pair, so in this case 2 lone pair are there on the oxygen and 1 lone pair is there on the nitrogen atom. So because of lone pair, there is lone pair repulsions and lone pair bond pair repulsions as well. So because of these repulsions, the deviations happens from the idealized shape of the molecules. So yes, the answer is option 3, that is the repulsive effect. That is the repulsion because of the lone pair. Now question number 89, which says what is the compound A in the following sequence of reactions. So okay, let's do it here. So we are having orthobromotoluene. So first of all, magnesium is added in the presence of ether and then hydrolysis. So when magnesium is added in the presence of ether, so we will get MgBr. And whenever hydrolysis happens, we will get this toluene. Means of course H will attach here and we get MgOH-Br. This is the first step that happens. So this we get toluene, and we know that toluene on oxidation with KMnO4 followed by hydrolysis will give you benzoic acid. So it means the answer is going to be option number 1, which is benzoic acid. So the formation of benzoic acid takes place. That is the answer. Question number 90. Identify R and A for the given reaction. So here we can have a look that RBr is given in the presence of magnesium dry ether. So of course it will give rise to Grignard reagent, which is RMgBr, and in the here we have been given formaldehyde followed by hydrolysis, and we get isobutyl alcohol. So CH3C, CH3, CH2OH. This is isobutyl alcohol. So we know that formaldehyde on reaction with Grignard reagent gives a primary alcohol. Primary alcohol. So means this group, this one is coming from the formaldehyde. So it means that we will get RCH2OH. So this R group is this. So here we can say this R group is isopropyl group, that is coming from the Grignard reagent. So yes, we can say in these options that R is our R group and this is RMgBr. So isopropyl group is there. The answer is option number 4. Question number 91. Solubility of NiOH twice in pH 12 solution is. So we need to find the solubility. So pH is 12 and we need to find the concentration of hydroxide ions. So POH is, so you know that pH plus POH is 14. So POH in this case would be 14 minus 12, which is 2. So it means the concentration of OH negative is 10 to the power minus 2. Now nickel hydroxide, it will be ionizing as nickel 2 plus and 2 OH minus ion. So in this case the KSP would be Ni2 plus and OH minus square. So let's we need the solubility of Ni. So Ksp is already given 10 to the power minus 16. Let's take it to be S. And OHS is given 10 to the power minus 2 raised to power 2. So it's coming out to be 10 to the power minus 12, which is the concentration of nickel or solubility of nickel. So that's the answer. Question number 92. Which of the following molecule has net zero dipole moment? HF, its dipole moment is not zero. Okay. Like this. H2. Oh, now if I talk about H2O, again in H2O, alright, there is no symmetry. So again there is no net dipole moment. Like it's not zero. In BF3, actually we all know that BF3 it's a trigonal planar molecule having 120-degree bond angle. So all the three bond moments, they give a net sum of 0 because resultant of +2 of any 2 is equal to the third one in this case. So in BF3 it's 0, and then in CHCl3 again it's not 0. So in BF3 molecule, boron trifluoride, it is equal to 0. Now, which among the following is the strongest oxidizing agent? So we know that hydrogen peroxide, ozone, potassium dichromate, potassium permanganate, all are oxidizing agents. But ozone is a highly reactive molecule because of a weak bond between the oxygen atom. So it gives the nascent oxygen readily. It gives out readily the nascent oxygen. Potassium permanganate is stronger than potassium dichromate. Okay, hydrogen peroxide is also a strong oxidizing agent, but if we compare all of them, ozone will be the one which is the strongest because it can readily give out the nascent oxygen more than KMnO4 as well. Question number 94. So there is a reaction given in this case and we need to write the sequence. Okay, so here we can see that ketone is being converted to alcoholic group here. Okay, and here aldehyde is being converted again to the alcohol, that is the tertiary alcohol. So let's see what happens. Firstly, we are having this aldehyde group, so we will be adding Tollens reagent to it, which will convert this aldehyde to carboxylic acid. So firstly, Tollens reagent is added. Now we need to convert this carboxylic acid to alcohol, so we will be adding alcohol to it. Okay, that is CH3OH. We will be adding methanol and esterification reaction will happen. So when esterification will happen, we will get an ester in this case. Okay, so after that what will happen? We will be adding this Grignard reagent, and from Grignard reagent, yes, the ketone would be converted to the alcohol, and here the ester will be converted to the alcoholic group again. So yes, this is the correct order. That is option number A. First Tollens reagent, then methanol, and then the Grignard reagent, methyl magnesium bromide. Question number 95. Students, if the molar conductivity of 10 to the power minus 3 mole HA is 39 centimeter square per mole, then the dissociation constant will be. The molar conductivity is given for HA, means at infinite dilution. So you know that the dissociation constant, that is alpha, or degree of dissociation, is molar conductivity divided by molar conductivity at infinite dilution. So it is given 39, and for infinite dilution it's 390. So it's coming out to be 0.1. Now HA ionizes as H plus and A minus. If the initial concentration is C, it is 0. At equilibrium, let's say C alpha is dissociated, so the concentration left is C minus C alpha. Now the dissociation constant means the concentration of the product, C alpha into C alpha divided by 1 minus alpha, like C into 1 minus alpha. That is the concentration of the reactant. So now you know that this 1 minus alpha, like it's a very like alpha is very less, so we can neglect it as compared to 1. So it will be coming out to be C square alpha square upon C. So 1 C will cancel out and it will be C alpha square. So we know the value of C, concentration is given 10 to the power minus 3. Alpha we have calculated, we'll put it, we'll find the value of dissociation constant, which is 10 to the power minus 5 molar. Now, the elements in which electrons are progressively filled in 4f orbital are. So, yes students, we all know that the 4f orbital is filled in the case of lanthanides. Right? It is starting from like lanthanides. We know that lanthanum, it's like Xe5D16S2. Then the first member is cerium. So in cerium it's Xe4F1 5D16S2. So like from cerium up to lutetium, 4F1 to 4F14 are filled. So it means yes, the answer is option number 3, lanthanoids. According to molecular orbital theory, which of the following is true with respect to lithium 2 positive and lithium 2 minus? So you know that firstly, according to the molecular orbital theory, we will be finding out the bond order. Bond order is number of bonding electrons minus anti-bonding electrons upon 2. So this is the configuration for lithium 2 positive, which is sigma 1s2, sigma star 1s2 and sigma 2s1. So bond order is coming out to be half. Similarly for lithium 2 minus, it's again half. Now both of them are having same bond order. Now in this case, the species having less number of anti-bonding electrons, lesser number of anti-bonding electrons would be more stable. So you can see that lithium 2 plus is having 2 anti-bonding electrons, lithium 2 minus is having 3. So of course lithium 2 plus is more stable than lithium 2 minus. So yes, the answer is option 4. Next is when acetanilide undergoes bromination in acetic acid, the predominant product is. So we all know that acetanilide, here you can draw it, NHCOCH3. So this is acetanilide. So when it undergoes bromination in acetic acid, electrophilic substitution reaction will happen, electrophilic aromatic substitution will happen, and the bromine will be getting attached at the para position. So we will get para-bromo-acetanilide. The answer is option 3. 99, number of pi bonds and sigma bonds in the molecule. So here students, we can clearly see that there are 5 pi bonds. Now there are 2 benzene like rings. So 5 pi bonds can be seen. Now if I talk about the sigma bonds. So here if we count, there are 8 carbon-hydrogen bonds. And apart from that, carbon-carbon bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 carbon-hydrogen mean total 19 sigma bonds are there. So 5 pi bonds, 19 sigma bonds. The answer is option number 3. Next is pH of solution made by mixing 100 ml or 0.2 molar NaOH and 0.1 molar 400 ml HCl is. So we will be finding the number of millimoles of hydrogen and hydroxide ions, that is the molarity into the volume. So the number of millimoles of H plus ion is 0.1 molarity into volume. So that is coming out to be 40. And for hydroxide ions 0.2 into 100, it's 20. So there will be neutralization. Neutralization takes place. So how many hydrogen ions are left? 40 minus 20, that is 20. So concentration of hydrogen ions would be the concentration divided by the total volume, 100 plus 400. So it's coming out to be number of moles, it's there na 20. So it's 0.04 molar. From here we can find the pH. It's coming out to be minus log of hydrogen ions, which is 1.4. So that was our last question. That is the question number 100. I hope everything is clear, students. Thank you so much.